Graphing f of x equals ax squared plus bx plus c. Your state standards are given. I usually don't read these to you. It doesn't mean they're not important. It just means I feel like you can read these yourself. And a lot of these we go over in multiple lessons and multiple chapters. So again, be aware, these are your state standards. All right, to be successful today, you need to find the axis of symmetry and vertex of a quadratic function. You need to be able to graph a quadratic function of the form f of x equals ax squared plus bx plus c. And you need to be able to determine a maximum or a minimum value of a quadratic function. All right, couple vocabulary terms. You need to know what maximum value is and minimum value. All right, so the y-coordinate of the vertex of the graph of f of x equals ax squared plus bx plus c is the maximum of the function when a is negative. So when a is less than 0, when a, or your leading coefficient, is negative, your graph is going to turn upside down and you're going to have a maximum value. The y-coordinate of the vertex of the graph of f of x equals ax squared plus bx plus c is the minimum value of the function when a is greater than 0. So when a is positive, you have a parabola that turns up and you have a minimum value at the vertex. All right, so if a is negative, you have a maximum. If a is positive, you have a minimum. So you're going to have a maximum or a minimum, and it's all going to be determined by the a. All right, key idea for this lesson. This is very important. All right, so it again says the graph opens up when a is positive, and the graph opens down when a is negative. The y-intercept is c, so your constant value, that's your y-intercept, okay? And then the x-coordinate of the vertex can be found by doing negative b over 2a. And then your axis of symmetry is x equals negative b over 2a. Remember, the axis of symmetry goes through the vertex, so whatever the x value of the vertex is, that's also going to determine your axis of symmetry. So we're going to be using all of these facts to graph quadratic functions today, so make sure you have these in your notes. All right, for example 1, we need to find the axis of symmetry and the vertex of the graph. All right, so if you remember, the axis of symmetry is x equals negative b over 2a. So that means we need to know what a, b, and c are. So this is a quadratic function. So this is a equals 2, b equals 8, c equals negative 1. We don't need c for the axis of symmetry, but it's still good to know what those are. So x equals negative b, so negative 8 over 2 times a. Negative 8 over 4 equals negative 2. So that means our axis of symmetry, x equals negative 2. And remember, our x values, all of our x values, you can choose x's, plug them in, and solve for y. So if we want to find our vertex, we're going to use the axis of symmetry, which we know the axis of symmetry goes through the vertex. So we're going to do the same thing. So we're going to take the equation that we're given, and we're going to substitute negative 2 in. So all right, remember you have to do order of operations. So I'm going to have to square my term first before I multiply. So negative 2 squared is 4. I'm going to have 8 times negative 2, which is negative 16. So I'm going to have 8 minus 17, or negative 9. All right, so I can determine my vertex is my x and my y coordinate. And this is my vertex. All right, it says find the axis of symmetry. We did that. And find the vertex of the graph. We did that as well. So you've got axis of symmetry and we have the vertex. All right, I want you to pause the video, take a few moments, see if you can do the other one here. F of x equals 3x squared minus 2x. I want you to do the same thing. Find the axis of symmetry and find the vertex of the graph. Once you take a few minutes to try to do that, come back to see how you did. All right, hopefully you paused the video and took a couple minutes to do this. So if you look, you're going to do negative b over 2a again. So negative b is negative 2. So negative 2 over 2 times a. A is 3 in this case. So negative 2 is positive 2. 2 times 3 is 6. That reduces to 1/3. So my axis is symmetry, x equals 1/3. Then I'm going to take this original equation and plug in 1/3 for both of my x's. So 3 times 1/3 squared minus 2 times 1/3. I have to square my number first. So 1/3 squared is 1/9 minus 2 is the same as 2 over 1. So that just becomes negative 2 times 1 over 1 times 3. So negative 2/3. Multiplying fractions, you multiply the numerators and then you multiply the denominator straight across. So I got negative 2/3. And then 3 times 1/9, that's the same as 3 over 1. So 3 and 9 will reduce, 1 and 3. So that leaves 1 times 1 is 1, 1 times 3 is 3. So that becomes 1/3. 3 times 1/9 is 1/3. So 1/3 minus the 2/3 that was here. 1/3 minus 2/3 is negative 1/3. So my vertex is my x and my y value, so 1/3 and negative 1/3. So I hope you got that. If not, let me know. I'll be happy to help you do some more practice. All right, this time example 2 says graph f of x and find the domain and range. All right, so then we know that we can graph the vertex, and we also know that the y-intercept is c. So let's start with what we know. So let's start with finding the axis of symmetry and the vertex like we did in the last example. So we know that A is 3, B is negative 6, and C is 5. Okay, so I just got those numbers from the coefficients here, and then the constant value, the A, B, and C comes directly from the equation given. All right, now, so we know the axis of symmetry can be found by doing negative b over 2a. So x equals negative b. B is negative 6, so I've got a negative 6 again, over 2a. So I'm going to have 6 over 6. Again, a negative times a negative is a positive 6. 2 times 3 is 6, so 6 over 6 is 1. So x equals 1, that's my axis of symmetry. All right, and I can take x, plug it into my function, and find the y value. So y equals 3 times 1 squared minus 6 times 1 plus 5. Again, remember, always do order of operations. 1 squared is 1. 1 times 3 is 3. Minus 6. Negative 6 times 1 is negative 6. And then plus 5. So y equals 3 minus 6 is negative 3. Negative 3 plus 5 is 2. So my vertex is going to be 1, 2. All right, let's change this to black. Let's go ahead and graph the vertex. So the vertex is my x is 1 and my y is up 2. So that's my vertex here. And then we also know that the y-intercept equals c. So in this case, c is 5. So we know the y-intercept is 5. So we can go y-intercept is on the y-axis, so I'm going to start at 0, 1, 2, 3, 4, 5. And we know that the axis of symmetry cuts this parabola in half, so we can reflect this point over here. And we know that we have a point at 2, 5 as well, because parabolas, quadratic functions, are symmetric. All right, let's see if we can graph this thing. So you do need to have at least 3 points to graph it, or you're not going to get the quadratic, the U-shaped graph that you need. But if you have at least 3 points, you can graph the quadratic function. All right, now we know that we can also choose x's to the left or to the right of the ones we have and get more points. So that's why there's an arrow on the end of here. So that means in order to find the domain and range, we can look at the graph and quickly determine the domain and range. So the domain, you see it goes to the left and to the right. Your domain is your x's, so it's going to be all real numbers. And your range is everything above the vertex. So this is y equals 2. So it's going to be y, all values, y greater than or equal to positive 2. So we graphed the function. We found the domain and range. Wasn't too difficult, just using the steps that they provided for us. So I want you to take a few moments, pause the video, and try to answer the self-assessment. If you need to, plot the points and see what it looks like, and then answer the question. All right, I'll see you in a few minutes. All right, hopefully you took time to look at this, and what did you decide? Hopefully you came up with the answer of no. The y values are the same, okay? So we've got 3 and 3, which means the vertex should be the average or in the middle of that. And it's at 2, and this one's at 0, and this one's at 5. So this one would actually have to be at 2.5 in order for that point to be the vertex there. So can those 3 points fall on a quadratic graph? No, they can not. So the x's, the x coordinate of the vertex has to be the average of the other 2 points. So 0 and 5, take 0 and 5, add it together, divide by 2 is how you do the average. Take them, add them up, divide by 2, and you get 2.5. So again, that is 2, not 2.5. So those would not fall for a quadratic. Those points would not fall on a curve for a quadratic function.